So our session is a scikit-learn. So mainly it is used for the whether myself, my father having the diabetics, whether whether there is a chances where I am getting the diabetics, or whether I am having the diabetics, whether there is a chance my son will get the or my daughter will get the diabetics. So these kind of prediction mostly we will use the data. So that means our input is the data. Our input is the data. So we can able to do some analysis, or we can apply some the data science or some machine learning algorithm against with the data finally we can able to get some prediction from the data or some analysis from the data. So our input is data, and finally you do some work along with some process along with the data, we can able to get some prediction out, that is output of our data. If your input is wrong, so completely we may not able to get the proper prediction at the output. So that only the pre-processing, the word itself we can able to interpret. So we have to make the sure about the quality of your data. So whether nowadays lot of ready-made data set also there, or you can able to generate your own data set, or you downloaded somewhere, or you can get it from some source. So before you are going to apply the data with some process, we have to ensure that what is the quality of the data. Okay, because our main work is the data. I will tell one simple example. You see, suppose I think most of us are the faculty members. Okay, most of us are faculty members. So particularly in your subject, you assume that one student scored the mark 9. Okay, one student scored mark 9 out of 100. As a faculty, mostly we will more eager about the student's career, student studies. So what the faculty asked the student, so tomorrow you have to get the sign from that particular answer script in your parents. Okay, you assume that the student scored 9 out of 100. If the students carrying the mark and show to the parents, what is the parents' reaction? So whether the parents will appreciate the students? Definitely it is not like what the parents will do. So the parents, either the parent may scold or they may beat, because he scored only 9 marks out of the 100. So what the student did, on the way the student had 1 0 along with the 9. Now you see that what is the value instead of 9, now the mark is 90. So now the student show this paper to the parents. So now you see the reaction about the parents. So definitely the parents will appreciate the students, correct? Particularly his son, and he may give some chocolates or give some gift to the particular guy because he scored very good marks. Now you see the difference, the reaction between or the decision about the parents. Whether it is a 9, what is the reaction? Whether it is a 90, what is the reaction? You see the difference because of the only 1 0. Whether it is a 9 means they are going to beat. If it is a 90, they are going to give some chocolates or they are rewarding particular guy. So that the data, so that only the data is very, very important. So that only the pre-processing, whenever we are doing, you may work with the n number of applications or n number of problem domain. So whenever you are dealing with any kind of machine learning algorithms, you have to make sure that the quality of your data, whether the data is pakka. So then only we can able to use further analysis. If the data is wrong, the whole your process will not mislead to the a wrong perception, or you may get the some wrong lead to the answer. So that only pre-processing will be very, very important. Then you see the dimensionality reduction. So sometimes you see, for example, in your university or in your college particular students database, you have the student database. The students may having that particular one department, for example, computer science department, first year, second year, all the fourth year students will be there. So and in particular take the one student, for example, he is studying the 8th semester, his first year, all the first semester, second semester, third semester, all the details will be there. Suppose and their hostel, parents details, so much of particulars will be there. Suppose if you want to do only the attendance calculation about the particular students, in that calculation you no need about his marks, you don't need about his hostel. So only if you need the attendance about the particular student, no need to the other features. So the word normally the features, or we can call it attributes, or we can call it columns, or we can call it a dimension. So no need to do the all the features. So we have to reduce the feature. Otherwise it will time consuming. Your process will take the more time consuming. Is correct. So no need to use the all the features for the particular process. Sometimes you have the in your CSE department, if you want to work with only the first year student, then why should I use the all the second year, third year, fourth year students? So you have to remove the other students. That means second year, third year and the final year. So either we can reduce that column wise, that means the features wise, or we can reduce the record wise. So both reductions we can able to do. So that also we can able to do with the help of the your scikit-learn. Then classification and regression, clustering. So these are the some of the application about the machine learning. Later I will explain with one or two example. Then with the help of that, we can able to build the model. So that model in the sense, for example, when we are using the any one of the machine learning algorithm, using the machine learning algorithm, we will use the model. What is the use of the model? Later the model will predict the features. Correct? With the help of, for example, if I want to predict particular one student is studying in the 6th semester. So now only the semester started. Okay, I want to predict how much he will score in the end semester. Okay, now only the semester started. One students newly the courses started. For example, 6th semester. I want to predict to the particular one student how much he will score in the end semester. So we are not astrologer, correct? We cannot able to straight away predict that he may score 8 CGPA or 9 CGPA. For that we need some reference. So we have to see that what is his scored in the last 6 semester. What is the percentage he scored in the first semester or second semester, third semester. After analyzing all the five semester marks, we can able to approximately predict how much he will score in the end semester, correct? So that only we need that your model, your whatever the machine learning algorithm, we are using the machine learning algorithm. That machine learning algorithm we will use with the help of the last 5 semester data. With the help of the last semester 5 semester date marks, your model, that means the machine learning model will predict how much you will get in the next semester. Suppose your model will not able to predict properly, we can able to tune the model, we can able to adjust the parameters of the model. And so then how your model is predicting? In the machine learning algorithm, n number of algorithms are there. Okay, you may have their decision tree, navy base, support vector, mission random, for so much of algorithms are there. We can use any model or any machine learning algorithm to the particular problem. So after that, we can able to evaluate or we can able to measure how the model behaves, which model is the best model, correct? Among the 10 students are there in our class or 100 students are there, we have to evaluate which is the best student. How will you evaluate? Mostly we will conduct the exam who scored the top, or in the attendance who is a very regular student in attending the classes. Some criteria, some measures we will use to evaluate who is the best one. Similarly, in the model also we have to use some of the measures to evaluate which model is the best model. That also we can able to see. Okay. So the scikit-learn is mainly used for the predictive analytics. So now you see what are the other kind of analytics will be there whenever we are studying the data science. I hope you may heard this slide or this analytics earlier in our some other session, some other experts presentation. So when we are starting the predictive analytics, so we have to do the descriptive analytics, diagnostic analytics, then only the predictive, then prescriptive, then cognitive analytics. So all the analytics are in the hierarchical manner. Okay. So descriptive in the sense the past. Descriptive in the sense the past. For example, I tell one simple example. When we are running a business, okay, when we are having one business, you are running one simple supermarket, okay. So you are running almost 10 years. So last years your business got down. That means your business 2 lakhs loss. That means what happened your business. So you are analyzing the last 1 year your transactions. So that is a descriptive analytics. Then we are analyzing that why it is happening. That is a diagnosis. We want to analyze the reason behind that how my business got lost. Maybe near to your new supermarket may be opened. So that is a diagnostic analytics. Predictive analytics. So predictive analytics in the sense, so if your business are running like that only, what will happen in the next year? So this year 2 years loss, maybe 2 lakhs loss. If it is goes like that, what will happen in the next year? So that will be the predictive analytics. And prescriptive analytics. Suppose if you want to make my business in the profitable level, what action I have to do? So whether we have to introduce some discount or we have to make more offers or some home delivery. So we have to think the possible courses of action. In what way we can able to achieve my business in the best level. And another one important analytics is the cognitive analytics. That is in the word that is nowadays recent analytics, most of the applications we can use. So nowadays most of the applications we can use along with the AI based application. Okay. I hope in your mobile normally we will use the Google Assistant. One app will be there. I hope everybody use the Google Assistant app. For example, now I am in Nagaland. Okay, now I am in Nagaland. So I want to come to your Chennai, okay. So once I landed the Chennai airport, so first time I am coming to Chennai, so I don't know any places in Chennai, okay. So simply I ask the Google Assistant, suggest nearby hotels, okay, or suggest nearby lodges. So definitely the Google Assistant, the app, it will suggest some of the list of hotels, maybe the user ratings, or maybe the reviews, or maybe the price. So it may be the based on the some parameter or some criteria, your Google Assistant app will some of the list of hotels suggested 1, 2, 3, 4. But who is going to take the decision? A human being. So either I may go with the first option or I can go with the second option. Sometimes I may not choose any one of the options. I may go the different one. That means initially we use the machine to apply the machine intelligence to get some suggestions. Finally, as a human being, we apply our human intelligence to take the decision. That means machine intelligence plus human intelligence, that is normally we called as the cognitive intelligence, or we can say it is a cognitive analytics. So nowadays most of the applications we can use that, some cognitive analytics also we can able to use. You see, so mostly our scikit-learn or with the help of the machine learning algorithm, mostly we will use the predictive. The word prediction, we can say it is a future. So tomorrow, everybody want to know tomorrow what will happen. So this month, now we are working, most of the people, we are in faculty members. So next year, how much salary I will get, when I will get the increments. It's correct. Everybody, we want to know more about the futures, what will happen in the next. So that is a prediction. So using the machine learning, we can able to do some prediction. If you want to do the prediction, definitely we need the past data. With the help of the past data, we can able to predict the future. So that is a simple logic behind your machine learning algorithms. Okay. Here I will say simple one example here I suggested. Everybody, we are having some experience with the online shopping. Nowadays most of the things, because sometimes we can able to get the very less price when we are going to buy in the shops, okay, even mobile phone or anything, whatever you want, anything nowadays we can get it either Amazon or Flipkart, okay. Price also less and no need to go to the particular shops here and there searching also. When we order, automatically it will come to your home delivery, okay. So you see Amazon, whenever we are searching some product, whenever today you are searching some product, last 1 week we are searching one product, you didn't order the item. So whenever you are next time when we are searching, so definitely your Amazon, that site will recommend based on your earlier searching, okay. So whatever you ordered earlier or whatever you were searched in the earlier, based on your searching history, the particular website, either Amazon or Flipkart, it will automatically recommend. Maybe you searched some mobile. Today the mobile price may be reduced, means definitely you will get some pop-up. The mobile price maybe today you may give some offer is there, or particular one credit card you may get some 5% less discount or a 10% discount. Some notification you may get it through that one. So these kind of examples we can say is some kind of predictive analytics. So based on your searching history or based on your earlier searching or based on the earlier your purchase behavior, the site will predict or site will suggest something new to you. So these are some of the example we can say with the predictive analytics. So this is another one AI based some real time example. We can say it's a real time data analytic. You see, so nowadays in every cities we have the n number of big malls are there. Okay. So when the one particular persons, one is entered into the mobile. So when the entrance, they are having the camera, CCTV camera is there. So first you have to take the photo of the particular person while you are entering into the shop. Okay. So once you are entering into the shop, then take the photograph. Then we have to search whether it is a new customer or whether it is a existing customer. Okay. Then you, based on your image, it will search your complete existing customer list, whether you are the new customer or you are a existing customer. If you are a existing customer, then definitely your last purchase behavior will be there. What are the items you purchased for the last time visit or earlier visit, all your visit, what are the items you purchased. So based on your purchasing behavior, or based on your purchase history. So definitely whenever you are going anywhere, so definitely we are keeping the mobile. So nowadays you can able to see without mobile, we cannot able to see any persons, correct? So in your mobile, automatically some notification will come. So they may recommend some items based on your earlier searches. So these are the new models arrived, or these are the particular models, the price got reduced. So no need to you ask anything, and immediately in your mobile they are giving the some notification based on your purchase history. So then after that also where it will be available, after you are buying all the things, if you are putting in that particular basket, so the things, the automatically we can able to analyze the your buckets, what are the items you put. They may give another notification that if you are buying above 5,000 rupees, you may get some 2-liter rice free, or 2-liter oil free, or one sari free, or one chudidar free. So these kind of notification automatically come to your mobile. So no need to discuss anything with the shop people, or no need to, you also no need to ask anything with that particular shop. So completely everything will be automatic. So these type of real-time data analytics nowadays it is going on. Okay. So now coming into the picture, next main term is that machine learning. The word itself, because our data science or scikit-learn tool is mainly used for the machine learning algorithms. So definitely we should know some idea about the machine learning. The word learning normally used to the human being, correct? Where we will use the term learning? So when everybody we have the some driving license, when we are going to get the driving license, what we will get initially we will not get the driving license straight away. First what we get the one learning license. What is the use of the learning license? That means we are in the beginner. So we will put the one elbow in the car. We are learning the vehicle. Is correct? That is a learning phase. So learning time what we will do, mostly if you are sitting in the driver's seat, definitely the driving school instructor will be sit along with you. That asides, one side the driving school instructor will be there. Your vehicle steering, brake, clutch, all the control will be in the instructor only. Anyway, even though you are sitting in the driver's seat. So initially 1 or 2 days the vehicle or the car is not in your control. It will go here and there. After 1 week, what will happen? You may get a little bit control. After 2 weeks, after 1 month, after 3-4 months later, so you will be in that more experience. You get more in that particular driving. So after 2-3 months later, no need about the instructor. You can drive your own to the any traffic place also. You can able to drive. So after 3 months, 6 months, after 1 year, or after 2 years, we can able to say that I am an expert in the driver. You can able to go for a long journey also. That means you learned last 1 year. That means you are learning 1 week, 1 month or 2 months of your long learning will be you are converting into the expert. Correct. You see now we are faculty members. You see, suppose if I am asking what is your favorable subject, some faculty may say that sir computer networks or a database, correct, or a data structure or algorithm is some different or operating system. In what way you are saying that I am familiar in operating system or my familiar subject is a data structure? So that subjects definitely you taught to the particular subject more than 5 semesters or more than 10 semesters. If you are taught one subject more than particular period, more number of times, you are experienced in the particular subject. That means you are expert in the particular subject. Correct? That means when your learning is more learning, you are expert. That part is related to the human being. Correct? Human being, when we are expert, when we are learning more, when we are spending more period in the particular learning, definitely we are in the expert. That means we are converting our experience into some expertise or into knowledge. A human being. But what about machine? Machine doesn't have the brain. Machine cannot able to learn. Correct? But the title is machine learning. But a machine also can able to learn. The diagram you can able to get thing from the diagram. You see the here the person saying that I can learn from experience. But the machine saying that I can learn from data. So here our human being we are using experience, whereas your machine can learn with the help of the data. If you are giving the more number of data, that's why I told you, if you are learning 2 years, you will get the more expert. If you are learned 2 days, you cannot able to get that level expert only will be having. So if your experience is more, you will be more expert in the particular domain. Similarly, if you are giving more quantity of data, past data to the your machine learning model, the machine learning model will predict more accurately. So for that only more training data, more samples data required for training the machine learning algorithm. Then only your algorithm can able to predict more accurately. If you are giving very less number of data, it may not able to go analyze more varieties of data, correct? So it may not able to predict properly. So if your machine learning can able want to predict more means, definitely we have to give the more data. So that is what that machine learning and the human. So that means the machine, we can make a machine to learn from the past data without the programming explicitly. Here I have specified one word, IBM Deep Blue. So participants, do you feel any difficulties in the sessions? How do you feel the session? Because it is a one way I am speaking, I want to know about the, you please put it something in the chat box whether okay, thank you. Good sir, thank you ma'am, thank you sir. Okay. Here I put one word below, the IBM Deep Blue. Anybody having any idea? IBM Deep Blue? Next I put the chat GPT, that everybody knows nowadays. So faculty or other, nobody is required, only chat GPT is required. Even student side also, faculty side also, administrative point of view. So nowadays chat GPT is the main part of our life. Then one more word I specified here, IBM Deep Blue. Any idea is there? Very good. Syed Ibrahim sir, very good sir. So it is a online chess game. Do you have the importance of the chess game? Any importance of the chess game? That chess game online, it is a one online chess game, but one beauty is there in the chess game. Very good sir, very good. So it is not now, it is developed in the year 1996, that period. Okay, it is a one online chess game developed by IBM company. So you see that important, it is just a machine game only. But at that time, the world chess champion is a Gary Kasparov. So this online chess game beaten the particular human being, not only normal human being, a world chess champion. So now you think about the power of the machine intelligence. So a machine game, just an online chess game, beaten the a world chess champion. So how much power that machine or machine intelligence, even though that is developed by the human being only, but the important, the way that more power of the particular machine intelligence. Okay. Nowadays, if you want to make more in that data science, or I want to make more, learn more about means, so definitely you have to do the some, you should know the artificial intelligence, then natural language, NLP means natural language processing, then the data science means not only data science, definitely you should have the strong knowledge about the some mathematics background, especially statistics, because your data science is some 50% part is the statistics and 50% on the computer part. So your more statistics, that means the mathematics knowledge also required. Another one is the cognitive science. So these are the some related area related to the our data science. You see here, somebody's, you may say that the statistics and the machine learning, or statistics model and a machine learning model. Your statistics normally we have that when we have take the particular one problem, we can able to get the data from the particular problem. Okay. For example, weather forecasting, last 10 years we have to collect weather forecasting my problem. I have to collect the last 10 years data. So that is the your problem along with the your data. So that is normally called as the statistics. That means another one aspect also we can able to see. So your statistics we can able to find some association between the particular data. The association in the sense, when we are talking about the data, two kinds of features will be there. So one will be the normally we can call it is a dependent variable, another one is a here in the you can able to see the graph, your dependent variable, another one is a independent variable. Okay, suppose your salary is depends on your experience, your qualification, correct? So now you are working with the, for example this year we are getting some 1 lakh or some salary assistant professor we are working. Okay, so next year you may complete it with the, your promotion will be there, then we can able to okay how much my experience is there, or how much my qualification is there, or how much I published my papers, or how much your credentials are there. Based on that, how much salary you will get, how much increment you will get. So your salary is depends with some other factors, some other features, your qualification, your promotion, your publications, your projects, correct? So many factors are there. So these are the independent. So based on these features, your salary will be incremented. You may get the increments. So your salary is the dependent variable and your experience or qualification is the independent variable. So we can able to find the some association between these two factors. So with the help of the your machine learning, and that we can after that once we are finding the some association with the help of statistics or machine learning model, then we can able to predict okay now my salary is like that, after 5 years how much salary I will get. Suppose we are planning to buy home, or we are planning to buy a car, we have to pay the EMI, correct? Or your son's future studies will be there, some education purpose will be, some requirement will be there, features. So now my salary is like that, can we able to buy a car, or can we able to buy a home, because next month or after 2 years how much my salary will be there. So based on we can able to make some EMI, correct? So that kind of prediction we can able to do with the help of the machine learning. You see one simple example here I can stay here. So when we want to able to predict the student, whether the student is a good student or whether it is a poor student, okay, when we want to prediction with the help of the machine learning, okay, we want to predict with the help of the machine learning. So general approach you see, so normally if the students, two factors I consider, one is a marks, another one is attendance. Okay, if I want to predict, or if I want to make, no need to predict, if you want to judge a student is a good student means marks should be high and attendance should be good, correct? Those who are having the good marks as well as the good attendance, I can say that these are the excellent students or good students. You see the green points, the student they scored the good marks as well as the good attendance, I marked as a one cluster, one round circle is a one group, I marked as a good students. Some students their attendance also low, poor, similarly marks also very poor. So I mark the student as a very poor, that means a poor student, because their mark also less, similarly attendance also less. So now you see in between one yellow color arc, I marked one dot, one student, okay, I marked as a B. The student range is, if the mark is coming exactly middle, the mark is coming exactly middle between the low and the high. Similarly, his attendance also coming exactly middle of the good and poor. So where I can put the particular student, whether I have to put the particular student in the good group or I can put the student in the poor group. So I cannot able to, because the mark is coming exactly the middle position. So here I am applying some the machine learning model. I am applying the some machine learning model. One simple approach I have, somebody you may know that the algorithm, K nearest neighbor algorithm. It is one kind of the supervised learning, machine learning algorithm, or we can say unsupervised learning also, this algorithm we can say. You see here, what is the algorithm it is using, that from the particular point B, K nearest neighbor, the word K, so the numbers, K represents the number, either 3 nearest people or 4 nearest people or 5 nearest people. Mostly the value of the K will be the odd number. Mostly the value of the K will be the odd number. Okay, either 3 or 5 or 7. So here I have to consider the value of K is 5. So from the point B, I find out the nearest 5 people. I am using the some distance measure method will be there. You may study the Euclidean distance or Manhattan distance. Some of the Euclidean distance measure will be there. With the help of that particular measure, I can able to identify the who are the 5 nearest people. Here I consider the value of K equal to 5. So after I identified the 5 people, I marked the circle. Then I identified the who are the 5 people. Now you see among the 5 people, 4 people are belongs to green and 1 people is belongs to the red. So 4 people means majority 4 people belongs to the good student and only one is the poor student. So we are going with the majority voting. So that means that point I have to consider as a good student with the help of the k nearest neighbor algorithm. So for getting the final, we are taking the decision based on the voting. So for that only mostly we are using that or considering the value of k will be always simple add. So this is a simple machine learning algorithm. How the machine learning algorithm is used for the some prediction purpose. So whenever you are doing the some predictive analytics, so these are the stages mostly will you do. Okay. So when we have the download the data set, so then we have to do the pre-processing. Already I told you the pre-processing will be very important. Then we have to divide your data set will be the two part. One is a training data set, another one is a testing. You see the divide. I didn't divide the data into equal partitions. So most of the data will use for the training data, and the rest of the very small quantity of data only will use the testing data. Then use the data, will use any one of the machine learning algorithms. Build the model. Then we are validating the model. After that, I am testing the model with the test data. How the model predicts, because the test data also result is there. You see, for example, I am giving the marks, 5 subjects students marks. I want to my task is whether the student is pass or fail. I am giving 5 subjects marks. Already I know the result. So what is the result of the particular model? What is whether model prediction value as well as the existing actual data value, if both the values are same, then your model is good. If the the result is mismatching, the original actual value is pass, your model is saying that it is a fail, then your model, we have to validate the model. We have to again redefine the model. So until unless we are satisfied with the model performance is okay, then we can able to use the model for the real time scenario. Then we can use for that, get the output. Here I will one simple example. So everybody we struggled almost 3-4 years back for the COVID. Okay. So this is the one simple data set, a COVID data set. So what is a symptom, whether we are having the cough or fever or whether we have the respiration or headache, then we can say it's a COVID positive or negative. So I have the last some 1,000 more data sets are there. Using that COVID data set, I used that data is called as the training data or historical data. I am giving that one machine learning algorithm. Okay, the machine learning algorithm will build the model. The model normally we are saying that it is a classifier. The model is saying that the classifier. What is a model? When we are saying that model, actually what it means, it is nothing but a simple if then rule only. Okay, according to the model will analyze all the data. It will say that if the fever equal to some value or cough some value and headache some value, respiration, based on that whether the result may be positive or result may be negative. Suppose if it is the result analysis, what is a, if subject 1 mark is greater than 40, subject 2 mark greater than 40, subject 3 mark is greater than 40 and all the subject is greater than 40, print pass, else fail. So this analysis, this if then rule, when we will construct, after your algorithm will analyze the whole huge quantity of data, then only the algorithm will give the model, we can able to find out the exact rule. So for that only we need the more quantity of data. Suppose in the data set I am having the only 3 data set is there. You assume that one student scored the mark 50, or you assume that one student scored the mark 60, another one student score the mark 20. Okay, only 2 students. Then how your model will what is a classifier? If mark is greater than 60, pass. If else mark less than 20, it will be fail. Okay, that is your if then rules, because your data set having only 2 samples or only data. One new student, the mark is 50. What is the model reaction? Because we don't know anything, because new data, it is unseen data, correct? So that the model may not able to predict pass or fail, because first time the model is seeing that data. So for that only your training data should be, we have to keep the more number of quantity of samples, then only your model can able to predict properly. So now we are constructing the model. Then you see after that we are giving the new data, your model will predict whether it is a correct or not. Okay. So this is that. So we cannot straight away give the data to the machine learning algorithm. So in between we have to use the pre-processing. Why that pre-processing required means, whenever your real time data, whenever you are taking the real world data, definitely the data will be incomplete. or the data will be noisy, or the data will be some inconsistent will be there. You see the data one here. Here the, for example, some of the values are missing, correct? The value incomplete means the values are missing. Some noisy, you see the mobile number, you see the, for example, the Kumar mobile number, he added the more digits, okay, it is a noisy. You are the Ajit age, it is a 350, instead of 35 he added one more zero, then it is a noisy, correct? And some student, it is a inconsistent means, you see some student, somebody, they may keep on changing the mobile number. Today one mobile number, tomorrow another one mobile number, correct? That means your mobile number is not a consistent. Whenever the values are frequently changing, that means it is a inconsistent. So most of the our real world data, it should be like that, whether it is a incomplete or noisy or inconsistent. So that only we have to do the pre-processing. Before you are going to do the data analytics part, we have to do the pre-processing. So these are the some of the stages. I am going a little bit fast, okay, almost data pre. So what are the stages will be there? So first we got to collect the real world data, okay. Then first thing is we got to clean the data. So what is the parts are there? We got to missing, if any missing value is there, we got to identify, and we got to noise. Suppose any error is there or some inconsistency there. Another one is outlier. So what is the meaning of outlier? So most of the data is an outlier analysis also one of the very good domain in your most some machine learning problems. Okay. So outlier in the sense some data point is extremely high. Some either extremely high also there or extremely low also there. Suppose you see the students marks. Okay, student marks. Some I am taking the 10 students mark. Okay, 10 students mark. So 9 students marks are in the range of 90. Only one student mark is 10. So that means we cannot say that 10 is a error value. It is also a mark. But when we are, it is a not related with the existing data set. You see another one simple example. For example, in your department, okay, 5 faculty members are working. Okay, 5 faculty members are working. 4 faculty members, their salary is in the range of 25,000. 4 faculty members, salary in the range of 25,000. Okay, so assistant professor entry level, one private college, they are giving 25,000. One professor, okay, one professor more experienced guy, his salary is they are giving the 3 lakhs. So one professor 3 lakhs and 4 faculty members 25,000. If I ask what is the average salary, what is the average salary about the particular department? So 3 lakhs plus 4, that means it will be the 4 lakhs divided by 5. So 4 lakhs divided by 5, how much it will come? Almost it will come, how much value? 4 lakhs divided by 5, almost it is in the range of 40,000, 45,000 in the range will come. That is the average salary. But what is the real scenario? The real scenario will be most of the faculty members are in the range of 25,000. Why this error comes? We cannot say that your calculation is wrong. Your calculation is correct only. But why it happens? Because of the inclusion of the high paid salary 3 lakhs. In that other salary 25,000, the 3 lakhs is the outlier value. So then this kind of calculation we should not include the 3 lakhs value. That is the 3 lakhs is a here outlier, because comparing with the other data points, other data values, some data value may be extremely high or low. That also we got to remove. Otherwise your final interpretation or analysis you may get the wrong value. So another is some data transformation. When we are collecting the data, in the data may be the different format. So we have to rescale the data, that is a normalization. Then we have to aggregate the data. Maybe the data may be the day-wise data. Then I have to aggregate to the month-wise, or some. We have to summing the data, make the data into the some aggregate form. Another one is the standardization. So standardization or standard scalar. So that means we have to map the value to that mean with the variance. Okay, then some statistics point. So that also very very important when we are making your data for the prediction process. Another is a data reduction. Already told you, either dimensionality reduction or a numerosity reduction, either attribute wise or a row features wise or a row wise, we can able to reduce the data set. Then feature encoding. So encoding the sense mostly your machine learning algorithm, that means we are going to use the computerized. In machine system will knows only the binaries, that means the zeros and ones, that means the numerical value only. Suppose your data is in the categorical data, sometimes for example your designation, professor, assistant professor, associate professor, we cannot enter the exactly the same value to the machine learning model, because machine doesn't know about the what is professor, what is associate professor, what is a professor. So we have to convert the categorical this type of value into the numerical value. That we have to use the the encoding scheme, one hot encoding, label encoding, so many encoding scheme will be there. That means your categorical value should be converted into the numerical value. So that work also we will do in the your pre-processing. Then what are the features or important features, that also we have to select. So these all part we have to give to the your prediction or machine learning algorithm. Okay, in that prediction there are two types of problem will be there when we are doing the your problem based on your problem. One is normally we call it as the regression problem, another one is we can call it as the classification problem. N number of classification algorithms also there and n number of regression algorithms also there. So what is this all comes under the supervised learning. Why the word supervised? Normally when we are doing the PhD, we need one person, that is a supervisor, correct? Without supervisor we may not able to complete your PhD. What is the role of supervisor? Your supervisor will guide you, correct? Supervisor will assist you. With the help of supervisor you can able to complete the PhD. So we complete the task. Here also the learning algorithm, your machine learning algorithm, here the supervisor is the past data. With the help of past data your algorithm will learn and we can able to do the some prediction, correct? That is a supervised. So here supervisor is the past data, so that only we can call it as a supervised learning algorithm. When we are using the past labeled data, we are using the label, already result will be there. Okay, suppose mark result pass or fail, COVID positive or negative, some disease, yes or no. So whatever your data set problem, we have the data set will be there. The data set class label, that means a result also there. Using the data set only we are going to use or build the model. So that only we are calling it as a supervised learning. Here our prediction, two kinds of prediction will be there. For example, simple same problem. So whether there is any chances for tomorrow, okay, whether there is any chances for raining tomorrow, or what will be the temperature tomorrow. Okay, we can say that whether it is a hot, or we can say that whether it is a sunny, or tomorrow raining will be there, yes or no. Your answer will be either yes or no, or hot or sunny, or sorry, hot or cool or raining. Okay, your answer will be discrete. The same problem, what will be the tomorrow temperature? The same problem only we can slightly change the problem. What will be the tomorrow temperature? Then what is your answer? Your answer will be 20, 21, 20.5, 22, 23. The value is the continuous value. It is not a one value. So if your problem having the multiple continuous values, then the problems comes under the regression. When your problems, your outcome is the discrete value, whether yes or no, whether I have, whether can I able to get the disease, yes or no. That type of problem normally we call as the classification problem. Okay, so both are different. How we can classify the problem means based on that what kind of value you are going to predict, whether you are predicting continuous or whether you are predicting the discrete. You see whatever I told you, the same problem. The temperature prediction problem, we can make it is the classification also, or we can make it is a regression problem also. Then another one learning is there, unsupervised learning. Mostly we will use for the clustering. So what is the meaning of clustering? Generally we can say that clustering is nothing but the grouping. Clustering is nothing but the grouping. Okay. So here one simple, one real-time example see. So normally when we are going, everybody we have some experience with whenever we are going to the supermarket or super mall, at the end of the billing section, the bill entry, that operator, first they may ask your mobile number. Okay, first without mobile number they may not able to make the bill. Why they are asking the mobile number? So after all the entry, you see after that we will get some notification. Mostly when we will get the notification, mostly the month first week, because month first week only most of the people we are getting the salary. So that time they will send some notification. If you are buying 5,000 rupees, we will give some 100 rupees coupon is free, or some discount is there, or some product now we are giving the 50% offer. So that type of notification will come. That notification also according to the customers. Some of the customers, every time whenever we are going to the shop, your purchasing habit will be, you will buy in the range of 10,000 to 15,000 rupees. Some people will buy 1,000 to 2,000 only. So those who are buying 1,000 to 2,000, that no need to give some advertisement. Correct? No need to target. So according to targeting the group, so that only we have to give this kind of clustering. Sir, I will give demonstrate some example also. Okay, don't worry, sir. Because practical in the sense, you see, it is a ready-made. Why I am giving more theoretical point? You have to get more idea about that, strong idea about the machine learning or the concept. Nowadays, all the things are plug and play. Okay, the coding part, everything is a scikit-learn is whatever the algorithm is here, just import the algorithm, import the data set, run the code, you may get the output. We don't know what is happening, how the things are executing inside, we don't know. Everything is ready-madely, it is available. First of all, we should know what is the result. When we are giving some data set, we are getting some result, how the result comes, what is the impact, how we can able to interpret the result. So that is very, very important. So when we are constructing the model, already the diagram also shows. So these are the things we have to do. Okay. So data pre-processing, divide the data, build the data, then you have to do evaluate the data, then we have to validate the model, then check the performance of the model, then only we can able to deployment. You see, whenever you had this term, underfitting or overfitting, I think most of your machine learning model, those who are people, those working with that one, sir, my model is underfitting or my model is overfitting. Why this error is coming? You can able to see this diagram. So when your data set is very small data set, when we are having the very less number of data set, your model, you see here the line will be your model. The dotted line will be the model and the dots will be the data points. The dots will be the data points. You see the underfit and overfit. So the gap between the line and the dot points are more in underfitting. Exactly in the model will touch all the points. So what is the meaning that when your training data set is very, very small quantity of the data set, then your model will touch almost all the data points. Then it will be the overfit. Your overfit error will be there. So what is the meaning of the underfit? So your data set having the more noisy. When your data set, you have the huge quantity of data. When your data set having the more noisy, more error will be there. Then your model will give the underfit. So you have to do some pre-processing. The pre-processing, you may have some concept that is a regularization. So with L1 regularization and L2 regularization, with the help of that, we can able to minimize the underfitting model as well as the overfitting. So we need the optimal, that is a best fit. So here the gap also there, but the gap is the minimal. That error normally we call as the residual error. The error will be less. That model normally we call as the optimal or best fit model. Another one problem will comes mostly when we are dealing with the data set. We use the term normally imbalancing. Okay. Why the term imbalancing in the sense? For example, you see, your problem is the cancer prediction. Okay, you are doing some problem. Your research or your work is the cancer prediction problem. So you take the one data set. You have the data set for the cancer. What is the real data set? If you take that some 1,000 people, among the 1,000 people, mostly 999, more than 990 people having the normal. Hardly 5 people or 10 people only the cancer, particular disease will be there. So that means your most of the data set, that particular data sets are normal people, very rare to some less number of percentage of people only having the particular disease. That means normal and diseased people. So your data set is a imbalanced data set, not a balance. So if you are using the imbalanced data set, what happened? Your model, whenever you are giving the normal person data, your model will predict exactly normal. Whenever you are giving some diseased person, your model may not able to predict properly because you trained the model with less quantity of diseased people sampled. So that only whenever you are giving the data set to the model, we have to check the entropy of the data set. We have to check the purity of the data set. How the class labels are there, whether the class labels are balancing or not. So if it is an imbalance, then we have to do some of the techniques. So these are the techniques will be there. Bootstrapping or resampling. The resampling, two things will be there. One is upsampling, another one is a downsampling. You see, so two way we can able to match the balancing the data set. Suppose you have the one data set, you assume that pass or fail. Okay, total 100 students, 80 students pass, 20 students only fail. So it is an imbalance. What way we can balance? Either you can increase the failure students or you can remove the pass students. Okay, one way you can increase the fail student also, you make it is the 80%, or you can reduce the 80% to 20% to match with the failed students. So two way we can able to balancing the data set. So that only one is the upsampling, that means increasing the minority classes, the failed students. Another one is the downsampling, you reduce the positive samples. So two way we can, so these are the some of the algorithms, SMOT and near miss. So these are the two algorithms mostly will use for the balancing the data set. So that is also very, very important. So these are the examples for the how what is a imbalanced data, undersampling what will be there and oversampling what will be there. Hello, Emma. Our class முடிச்சிட்டாடிங்க So what are the metrics are there for when we are normally when we implement in scikit-learn. So after you are using the particular model, at the last stage we have to evaluate the model. We have to evaluate the model, so that we have to use some of the classifier metrics. So mostly everybody you know the terminology accuracy, correct? We have to measure what is accuracy about the particular model. So before that accuracy, one important terminology will be there, that is a confusion matrix. First thing is we have to construct the confusion matrix. After that only we can able to identify the what is the accuracy about the particular model. Okay, that means your model, two things are there, actual one value is there, your model will predicted one value. Okay, your data set, for example, one is the your COVID data set. You assume that the COVID data set. COVID data set, what are the actual value will be there? Some cases are positive, some cases are negative. Your model will also predict positive and negative. So actual values and the predicted values. Both based on these two terminology, we can able to formulate or construct one matrix that is normally we called as the confusion matrix. Okay, the matrix, two things are there. One is a four terms are there. One is a true positive, true negatives. Another one is a false positive, false negatives. Okay, what is the meaning of the true positive? That means you see positive samples. Positive means COVID positive, actual value also positive, your models predicted also positive. That is a true positive samples. True negative. So true negative, that means actually it is a negative, COVID negative, your model also predicted as a COVID negative. So that is a negative as a negative. Then what is a false positive? So false positive in the sense, originally false positive, originally negative samples. For example, COVID negative patients, actually the patients are negative, your model is predicted as a positive. So what is a false negative means? False, the negative is a false. Actually positive samples, your people are COVID positive people, your model is predicted as a negative. So based on these four, we have to construct the, this is the confusion matrix. Okay, you already told you actual values and the predicted value. Here the diagram, little bit interesting, you can able to see that one. You see one lady is pregnant. Okay, actually pregnant, your model also predicted as a pregnant. That is a 1 and 1, both are same. So another one you saying that right hand side, see actual value it is a 0. That means a one gen is a normal person, but your model is predicted as a positive pregnant. Okay, so that is normally we call as a type 1 error. That means a normal person is identified as a COVID positive person. You see, a normal person is not any disease, but your model is predicted as a diseased person. That is a type 1 error. And what is a type 2 error? You see below, a pregnant lady, your model is predicted as a non-pregnant. That means a COVID positive person, your model is predicted as a normal person. Both are dangerous. You see, type 1 error, when you are building the model, your problem should not focus toward the type 1 error as well as the type 2 error. Type 1 error, what is the case? When the normal data, normal person should be identified as a diseased person. That is a type 1 error. What is type 2 error? A diseased person should be identified as a normal person. Okay, so both are will be the danger. So both the things will be the very dangerous. That is a type 1 error or type. Some problem we may focus on the false negatives. That means a type 2 error. So some research, some people they may focus on the type 1 error. So that is a false positive. So depends upon your problem domain or depends upon your application. You can able to consider either type 1 error or type 2 error. So this is what I told you. So this is the confused matrix. So using the confused matrix only we can able to evaluate the find out the measures. Okay, either it is a classifier, means we have to use the normally the accuracy. So here the TP true positive, false negative, false positive, true negative. how we are plot the values. What is the actual value and the predicted, your model predicted value. We are getting summing all the values in the matrix. Then we have to use the formula to find the accuracy. So how will you find the accuracy? You see, when we are run the model, when we are executing the model using scikit-learn or you will run the model using any one of the algorithm. Okay, any one of the classifier. At the end, the model will show the accuracy score. But we don't know how the scores are getting. So inside the real thing is the formulas are running. How the things are, you see. So true positive plus true negative divided by total number of positives plus total number of negatives. So according to that only we can able to get the particular accuracy values. What then another some other all the metrics are there, but it is a within the short period of time we cannot able to explain all the metrics. So error rate is nothing but the 1 minus accuracy rate. Another is a sensitivity. Suppose if you want to focus more on the true positive, you can use the sensitivity rate. Suppose if you want to more focus on the negative, true negative, then you can use the specificity. Another one is the precision. If you want to concentrate false positive, or if you want to concentrate false negative, that is a recall. Another one is a F1 score. So these are the some of the metrics we will use for evaluating the your classifiers. In the same sense, if you want to use the regression problem, continuous value prediction problem, mostly we'll use the mean absolute error. We'll use the metrics the mean absolute error or absolute error. So these are the some of the metrics we'll use for the regression problems. And how to choose the best machine learning algorithm for your classification. Already told you we have the n number of algorithms are there. You have the n number of algorithms are there for choosing the your classification or prediction problem. How to choose which one is the best. So these are the some of the simple guidelines. So what is the nature of your data? Whether your data more having the categorical data or numerical data. So mainly your navy based classifier will works on both. Your random forest will give more importance on categorical data, whereas your support vector machine good for the numerical data. If you have the more quantity, your data set is more on numerical data, better you go with the SVM. Suppose your data set is more with the categorical data, then you go with either decision tree or random forest. Suppose your data set is mixed, categorical also there are, numericals also there, you go with the some of the navy based classifier. And how much speed if you want to. Your navy base and SVMs are little bit fast, your decision base is little bit slow, because we have to construct the tree. We have to construct the tree and we have to pruning the some of the attributes. For constructing the decision tree model, it will take some more time, so that only that will be slow. Suppose you are handling the complex classification, your data is some non-linear, your data is some non-linear kind of data will be there, better you go with the SVM. So SVM is good for the numerical as well as the SVM is good for the some non-linear kind of data also. And if your data set is a more data set, huge quantity of data set, then you go with the random forest. So SVM is mainly used for the when we have the very limited small quantity of the data, because it is mainly used for the numerical data. So these are the some of the guidelines how you have to choose the machine learning algorithm for that one. So these are the some of the your scikit-learn. What are the things we can able to do? Already told you. So with the help of the scikit-learn, we can able to load the data, and we have to train the data, and the data pre-processing will be there, and model choosing, because already told you just to invoke the one line only from sklearn import decision tree or import support vector machine or import KNN, just one line, automatically we can import the particular model, and you have to set the parameter to the according to the model, give the data set, the model will your constructor, your classifier or model will give some outputs. Okay, so internally we don't know what is going on, but we should know basically how the algorithm works. What is the role of SVM? What is the decision tree? How the decision tree works? Straight away you are calling the decision tree or KNN or SVM or random forest. So before that, what is the exactly the algorithm is doing? How the algorithm works? How the model is behaving? Then what is the value of the final we are getting on the result? What type of result is there? Okay. Then the training data. Then the model tuning. Already told you some of you see n number of parameters are there, features are there. Among the features, which combination of the which feature will give the more accuracy of the result. Finally, we are getting the accuracy. We have the 100 features are there. Among the 100 features, we have to find the optimal subset features that will give the more accurate result. Features should be also less. We cannot use all the 100 features. Definitely we got to use the less number of features and we got to provide the more number of accurate results. So that is mainly we will use in your model tuning. And finally, I told you evaluation metrics. I told you here, you see, we have to find the confusion matrix. Then we have to construct the accuracy score, mean absolute error. If it is a regression problem, we have to use some R square also. Then some clustering problem. So these are the some of the things we have to use in the clustering problems. Okay, some. I will move to that some the demo, show some practical examples in that demo. So whether you have any doubts in the theoretical point of explanation?